Okay? So when you have a look at this, I'm going to think about some particular areas that relate to sine and tan and x. Okay? So if we call this, actually I shouldn't have called it theta. I should call it x, like I have in my heading. Okay? If we call this angle x, I'm going to think about 3 areas in succession. And you can see them all in this diagram. Okay? So the very first one is this triangle here, which has x in it. Here's the first area I'm interested in, okay? Now, I've chosen this as an arbitrary circle, so let's make the radius r. Okay, it's there and there. Now, have a look at the triangle and have a look at the information that you have. What is the area of this green triangle? You don't have a base and a height that are perpendicular to each other, so you're going to have to use the trig result for the area of a triangle, right? Which is half AB sine C, right? Except these are your A and your B, and this is your C. It's the included angle, so everything looks good. So in this case, I'm going to use my green, okay? The area of the triangle, this is the little triangle, is going to be a half r squared, there's my A and my B, sine x in this case. That's the included angle. Is that okay? All right, so far so good. That's my area that's connected to sine, okay? I'm going to think about a new area now. I'm not going to color all the way over it because otherwise I'd ruin my whiteboard markers and this would just become a rainbow disaster. But I'm going to consider taking that triangle you just worked out and adding this little strip. It's a segment, isn't it? If I added those together, what shape is this total colored figure? This is called starts with an S, slice of pizza. It's a sector. Right? It's a sector. So what I'm going to do is work out the area of this whole, it looks sort of like that. That sector. Okay? Now, we just established a formula for this, right? What is the area of a sector now that you know all your radian measure stuff? I'll give you a clue. It starts off remarkably similar to this. Yeah, it's going to be a half r squared theta, whatever your angle happens to be. My theta in this case is x. Okay, now let me just pause here to point out. These two are connected, right? Do you see that no matter what x you chose, this sector is bigger than this triangle? Do you agree? Like, the sector includes the triangle every single time. So the sector will be a teeny bit bigger than the triangle. Are you okay with that idea? Okay, there's one more area. I've got x, I've got sine. I'm looking for tan. Okay, now where is tan? Well, think about this diagram that I had before, right? And why tan has its name, and have a look at the diagram. Where do you think we might find tan? What feature do you think might be relevant? What's tan short for again? Tangent. And what do you see in this diagram? A tangent, right? So I'm going to use this whole big triangle here that's based off of this tangent, okay? So I'm going to now color it in, this guy over here. So now I'm considering the whole lot. It's the area of, I'm going to draw it like this because that's its shape, this big triangle here. And I know that it's right angled. How do I know that it's right angled? Think back to last year. The tangent is perpendicular to the radius at the point of contact. You agree? Okay, now this is kind of handy because if it's perpendicular, then this can be the base of the triangle and this would be the height. So I have a formula for that, right? The only catch is I don't know what the height is in this case, okay? So I want you to think back to yesterday when we derived the trig expansion for sine A plus B, right? Do you remember we had a look at all these different lengths in the diagram and we found them in terms of trig ratios, sines and cosines and all that kind of thing. So I want you to have a look. This is the side I'm after over here. Again, you've got some clues. What can I write that will help me get to an expression for the length of this side? A good clue is to start with tan, right? I'm just going to write it over here as rough working. The only angle that I have in this case is the x. So tan x. Well, I can, even though I said let's get away from this, I can still use all of these definitions. They still work, right? So tan is going to be, if that's where x is, then this is opposite on adjacent. This is my mystery side on top of my radius, which is right beside me, right? So what's my mystery side going to be? It's going to, have a look. I'm just going to multiply across by r, right? So this is going to be r tan x. Are you okay with that? You see I've just multiplied both sides? Okay, so now you can tell me, what's the area of this big right-angled triangle that encapsulates everything? Yeah.
Half r squared.
Half, because the formula for the every triangle with this is half base times height. My base is r. My height is that. So there's an r, and then there's another r, and then there's the tan x. Okay? Now, let me point out two more things. Remember how we said this sector must include this triangle and be a little bit bigger. Do you remember that? This sector includes this triangle and is a little bit bigger. Well, the same thing is happening with this big red triangle. Do you notice that? Like, it goes outside the circle, so it must be bigger than the sector. Yeah? So in fact, what I can establish is this set of inequalities. This is why I've done it in this particular order. I've started from the smallest shape on my diagram, and I've just gotten bigger and bigger and bigger. Are you with me? Is that okay? The second thing I want to point out is this formula right here in the middle, right? It relies on the fact that x must be in radians. Do you agree with that? Like, we could only start using this formula for the area of a sector once we learnt what radians were, okay? So all of this only functions in radians. So I'm just going to actually put that, it's so important, and it'll come back to bite you later. I'm going to put this right up the top. It's only in radians. Okay? Because if you weren't in radians, that would not be the area of a sector, right? You can't just put in like 30 degrees. You'd get an enormous number, okay? You'd put pi on 6 or something like that. Okay, now we're trying to get to this relationship, right? Sine x, tan x, and x, okay? Well, I can just get those by themselves if I get rid of all this extra fluff around, right? See, you've got this constant hanging around. I'm going to divide everything through by that. But just a caution, you know we're dealing with inequalities here, right? So you know when you divide or multiply by things, when you're dealing with inequalities, you have to be careful about the sign. What will happen to the direction of these inequalities when I divide through by half r squared theta? What will happen? Will the inequalities change direction or not? They will not. What's the reason why?
Squared.
Two reasons at least. It's squared, so it's positive, but also it's a radius. It was positive to begin with, okay? So I'm definitely divided by something positive. So what I'm getting is this. Sine x is going to be less than x, which is going to be less than tan x, okay? How are you feeling? All right, now, this is really good, but it hasn't quite gotten us to what I was wanting. My intuition was that these things, they all behave the same way when x is small. And I've got a relationship between them, that's something, but I don't quite have it saying that.